Okay, I want to start with that last problem in the web work. So you have to really, the instructions are leading you on a journey. You have to read them carefully and follow them precisely. Okay, you can't just kind of glance over the instructions and say, oh, I know what they want me to do, and just start doing what you want to do. So there's a very specific adventure that you're going to go on here. All right, so make that bigger. So let's do this part first. So it says that a group of people, 4 people start a rumor, and it spreads such that the number of people total number of people who've heard the rumor triples every 5 hours. Okay, so now we're going to fill in the table here. So at 0, there's 4. So then 5 hours later, how many will there be? 12. What did you do to get from 4 to 12? Multiply by 3. All right, so now 5 hours after that. What did you do? And then? So, what are we doing? We're multiplying by 3. And are we multiplying the output or the input by 3? And are we getting another output or are we getting the input when we multiply by 3? Which output are we getting? Are we getting the next output? We're not getting the next output. What output are we getting? Yeah, it's like 5 outputs later, right? So times 3, times 3, times 3. So is this the quote-unquote growth factor, 3? Let's be more specific. Which growth factor is it? 5 unit, or in this case, the 5-hour growth factor. All right, you multiply the output by 3. It gives you the next output 5 hours, or 5 units of input later. Okay? So that, most of you probably got that. So now notice that after 10 hours, how many people have heard the rumor? 36. So now they're saying, let the 1-hour growth factor, which we don't know, let it be B. Just call it B. It exists. So we don't know it without doing some work. We're just going to call it B. So now we're going to fill in the table below. And each entry must be an expression of B and the number of people who have heard it 10 hours. So at 10 hours, what was it? 36. Okay, so I'll do that up here. At 10 hours, we had 36. So if B is the 1-hour growth factor, then how many people have heard the rumor 11 hours? 36 times B. This is key, because this is the whole idea of exponential growth. If you multiply by the 1-hour growth factor, you're going to get the output corresponding to 1 hour later. So what about after 12 hours? Yeah, you could do times B if you wanted. So we'll do that for that one. And then if we go 1 more hour, it'll be B. We'll just do B cubed. Or B times B times B. Is this making sense? This is testing if you know the idea of exponential growth, which is repeated multiplication by the growth factor to always get the next output. And our growth factor is B. Okay, but we found, see look, 15 is 36b to the 5th, right? But we found what that number was up here. What was that number? 108. So this 36b to the 5th has to be the same as 108 people. Does that make sense? So if we multiply 36 times b 5 times, that'll be the number of people that know the rumor at 15 hours. And that should be equal to 108. And that's what C is telling you. It says they're the same. So now this gives you a way to find B, because they're the same. See that? So 36b to the 5th equals 108. I don't know why I put the caret in there. Just write an exponent, right? Okay, so we can solve that. We get b to the 5th equals 3. Which should make sense because what we're saying is b to the 5th is going to be our b to the 5th is our 5-hour growth factor. It's going to advance us 5 hours and give us the next output 5 hours later, but we already knew what that was. That was tripling times 3, right? So b to the 5th equals 3. That should make sense. So therefore, what is b? This is where we're going. B is 3 to the 3 over 5? Yeah, you had to take the 1/5 root of both sides to solve for b. So b is 3 to the 1/5. That's our 1 hour growth factor. So reasoning through this right here is crucial for understanding these multi-unit and partial unit growth factors. Can you reason through that set of steps that we did right there? So we'll practice it again. When we finish this, we're going to practice it again. Super important. Any questions? Does that make sense? Okay, so now we have the 1 hour growth factor. How could we find from that? How could we find the 8-hour growth factor? Okay, so this is the multiplier that gets us the next hour's rumor count. So we want it 8 hours later. What would that be?
3 raised to the 8.
3 raised to the, well, let's go, just go with there's our 1 hour. And what do we want to do with that? We want to multiply that. So every hour we multiply by that. So 8 hours later, how many times will we have multiplied by that? 8 times. So our 8-hour growth factor will be that thing to the 8th. Aaron?
So when I did this, I put 3 raised to the 8 over 15.
8 over 5/5?
Yeah.
Yeah, it's the same. But this shows getting the 8-hour from the 1 hour. You've got that 1 hour. You would multiply it together 8 times to get the 8-hour. So yeah, and that's equivalent to 3 to the 8/5. Yeah. All right, what about the 1 day? 1 day growth factor. So a couple different ways to do this. We can get it from the 1 hour growth factor, or we can get it from the 8-hour growth factor. Take your pick.
1 hour.
Let's do it from the 1 hour. So we'll just do the same thing again. So we'll do 3 to the 1/5. And how will we adjust that to get the 1 day growth factor? Raised to this, some people are saying it. To the 24th. Okay, what could we have done to the 8-hour growth factor to get to the 1 day growth factor? Take the 8-hour growth factor and do what to it? To the 3rd, because a day is 3 8-hour periods. So we could have taken that previous answer and just taken that whole thing and raised it to the 3rd, or we can take the 1 hour growth factor and raise it to the 24th. But again, don't jump right to a trick or a rule that you're going to find to answer these questions. Think about what it means. 3 to the 1/5 is what we multiply by every hour to get the rumor count the next hour. So you think about that. Okay, so then in 8 hours, boom, I'm going to multiply by that thing 8 times. So to the 8th would skip me ahead 8 hours. Okay? Keep practicing meanings. Keep practicing meanings. So we want now a function r that outputs the number of people who've heard the rumor t hours after it started. So r is the name. Input is t equals, what's our form for an exponential function? Initial value times growth factor, which we said was 3 to the 1/5. Right, after t hours, how many times will you have multiplied by 3 to the 1/5? T times. That's why we say to the t. Imagine 4 times. 3 to the 1/5 times 3 to the 1/5 times 3 to the 1/5 times 3 to the 1/5. T times, if we want to know the count T hours later. Okay, green bar. No, tan. I don't know what that is. I don't want tan. Oh, I see what it did. Okay, so it's expecting me. We just want T, that's all. All right, green bar. Green bar. Okay, questions on that? All right, let's have you guys try one.
Excuse me, I have a question. Can you put T in place of 1 on the equation?
What's that?
At the bottom. Did you use T instead of 1?
Did I use a T instead of a 1? Let me see. Let me bring it back. The last one?
Yeah.
So the very last one, I said this is A, B to the X, right? So 4 times the growth factor to the T. So what do you want to change?
Can you replace the 1 with T instead?
Yeah, so exactly. Yeah, that's the same thing, because basically what you guys are asking is, you know, Z to the A to the B is the same as Z to the AB. That's what you're talking about. Or Z to the 1 over C times D, or to the D equals? Yes. But I don't prefer that because I think it's harder to see what's happening. This way, in this form, if this is T, whatever increment you have, and it's this hours, then immediately tells you that this is what growth factor. If T is in hours, then this is the 1 hour growth factor. You do the T over 5, 3 to the T over 5. Well, what's the 3? It's a little bit, you have to kind of... Well, let me see. It would take me T equals 5 hours in order to multiply by 3, so 3 must be the 5 hour growth factor. So it's okay, it works, but it takes a little more thinking or a little more work to figure out exactly what the 3 is. Okay? Here, if T is in hours, then boom, that's the 1 hour growth. Whatever the unit that thing is in, that's that growth factor for that number of units. Okay, did I answer it? Good? All right, so let's have you guys practice one. Okay, so here's your table. Let's reset it here. Okay, so initial mass of 50 micrograms doubles every 7 minutes. Let me make this smaller. Okay, there we go. So initial mass of 50 micrograms in a Petri dish doubles every 7 minutes. Complete the following table. Round the mass values to the nearest hundredth of a microgram. Okay, so I want you to practice this process. So actually, I'm going to hide these. That. Okay. So start with that. So it doubles every 7 minutes. So let's first make this table. I'm giving you a 0, 7, 14, 28. Should be 21. That should be easy. Okay, so who's going to help me with this? Cameron, tell me what mass do I have after 7 minutes? 100. And then what about after 14 minutes? Kelly? 200. And then 21 minutes. What'd you say? I've changed this. It should be 400. I changed the input. Okay, good so far? So now we want to pretend we don't know anything. And now we want to break this down by hour instead of by 7 hours. So it's easy by 7 hours. It just doubles or minutes. It's easy. It just doubles every 7 minutes. But now we want to break this down. What we really want to know is what is this factor, the 1 minute growth factor? Because from the 1 minute growth factor, we can easily find all the other growth factors. So pretend you don't know a formula or a trick to get this quickly. What are we going to do? So we're not sure what the 1 minute growth factor is. So, like the web work problem, what can we do? Abdullah.
50 times B.
What's that?
50 times B.
Right, so call that 1 minute. Let's say the 1 minute growth factor is B. So we're going to say the 1 minute growth factor is equal to B. It exists. We're not sure what it is. So we'll call it B. So then you said 50B. What's that? Abdullah? 50B is what?
Trying to find that out.
50B? Trying to find out.
No, the one plus 5.
Right, but you said 50B, right?
Yeah.
What is that? What's 50B?
It's 50 multiplied by the voltage plus 5.
And why did you say that? What does that give you? How is that relevant?
After 1 minute.
He's saying it's the massive bacteria after 1 minute would be 50B. Agree? Yeah, because if it's a growth factor, if it's a 1 minute growth factor, if we multiply this output by B, it's going to give us the output 1 minute later, and that's 50B. Make sense? Okay, so now continue this way, finish the table, and then this is going to help us to determine what B is, right? So working through this process, using B as the 1 minute growth factor, it's going to help us figure out what exactly is B. So I want to see what you have in your table. Show me your table. This is what was 7B. That's the key right there. Because we know what that number is, right? What is that number? What should be the 7? Keep going. Go all the way to 7. 107. So I know that we've already got 107. But the point is that you're going to take this all the way down to 7. So all the way down to 7. Okay, but this process is work. Good, nice. All right, so what's the mass after 2 minutes? Let's see. Jonathan, did you get that? 50 times B times B. Exactly right, 50 times B times B. 3 minutes, Jake.
50 times B times B times B.
Oh. Okay. How about after 4? Let's see. Faisal. 50 times B to the power 4. Okay? So however many minutes has gone by, it's going to be 50 times B to that, or 50 times that many of B's, right? That's what we've been working on for the last 2 weeks. So by the time we get down here to 7, we know it's 100, but in terms of this pattern, what would it be, Nathan?
50 times B to the 7.
Times B to the 7. 7 minutes later, we will have multiplied by B 7 times, because it's 1 time for every minute. So this is the key now to getting that 1 minute growth factor, because those have to be the same, right? Those have to be equal. Dan, help me. Tell me.
Oh, well, I don't know, like this thing, I don't know how it's called, but it's the square root with the number in the corner of it.
So it's 7th root.
Yeah.
Is that what you want? So, but start me off. So what am I going to do first?
So first you're going to divide 100 by 50.
Okay. So I think, so we got 50 B to the 7th equals 100.
Divide both sides by 50.
Yep.
So now you got B to the 7th equals 2. And now you square 7th root it?
7th root.
Yeah, do 7th root 2.
So 7th root of B to the 7th is B. That's what we want. So then we have to do it to both sides. 2 to the 1/7. Okay, so now I want to find the 1 minute percent change. Let's practice that. How would we find the 1 minute percent change? What do we need to do for that? Okay.
The value of it.
Okay, good. Yeah. So I'll do equals 2 to the 1/7. I get this. So therefore the 1 minute percent change is? Let's do a little bit more than that. Let's be a little more precise than that. Not just 10. Subtract 1, but the final answer, a little more precise than just 10%. A more precise number.
10.4.
Yeah. We could even do 10.41. Okay, so yeah, where does the percent change come from? It comes from the corresponding growth factor. So our growth factor, our growth factor is 2 to the 1/7, which is 1.1040895. So we're looking at 10.41% growth. Okay, so then the 4 minute percent change is just 4 times 10.41%, right? I got a shake, I got a sour look. So instead, how am I going to find the 4 minute percent change? How do I get the 4 minute percent change? Yeah, is that?
You take your 1.01 or 1.04 raised to the 4th power.
And what would that be? What would that mean?
That's going to be your 4 minute growth factor.
Right, so to get the 4-minute percent change, we got to have the 4-minute growth factor. That's the only place that thing comes from. So our 4-minute growth factor will be 2 to the 1/7 to the 4th. Why? Because we multiply by 2 to the 1/7 every minute, then in 4 minutes, we'll have multiplied by it 4 times. Okay, and we get a value for that. .486. What's the 4-minute percent change? 48.6%. 60. Because it's 599. I want you to use the simplest way to find the mass at 18 minutes. Go. What's the simplest way, the most efficient, quickest, easiest way to get the mass at 18 minutes? Everyone do it. What are you going to do? All right, once you have the simplest way, then I want you to write 2 other ways to get it. Okay, this is what you can do if you understand exponential growth. You can find the mass at 18 minutes in half a dozen ways. So use your creativity. First of all, do it the simplest way, given everything we have, and then 2 more ways. 2 more ways to come up with the mass at 18 minutes. And then compare what you're coming up with the person next to you.
Yeah, I know. This is like, yeah, no. Pretty much just it's not even solving actually the value to it. This is 7. Yeah, cool. I don't know what else. Yeah, because I'm not rewriting that 18 times.
Okay, most efficient way. John, you're up. It's the easiest calculation I can make, given what I have here, to get the mass at 18 minutes.
2 to the 1/7 to the 18th.
2 to the 1/7 to the 18th. Is that the mass? Is that the mass, John? What is that you just said? It's not the mass. Yeah, this isn't a mass because this is a multiplier, right? This is what you would multiply by the mass to get another mass. Okay? So which multiplier is this? You just found the... Yeah, that's the 18-minute growth factor. Is that using that, is that the most efficient way? There's something easier than that. Yeah. Given what we've done so far, what's the most efficient way to do this? Anyone? Michael?
I would assume 2 to 18 over 7, or you could just say function of 18 depending on what you're looking for.
No, but that would take building the function and plugging in 2. I want something much faster and easier than that. Much faster and easier. Yeah, I mean that's okay, but that would take work. We'd have to build a function, and then we'd have to plug 2 in. There's something a lot quicker way to do this. Faisal.
You take the 50 and then you multiply it by the 1 minute growth factor, the power of 18 times.
Okay, so he wants to do 50 times this.
The 1 minute growth factor.
Yep. Okay, that works, but it's still not the easiest. So yeah, 50 times 2 to the 1/7, 18 times. That's basically using the 1 minute growth factor, like that. Nathan.
Take 200 and multiply it by the 4 minute growth.
Yeah. All we'd have to do is take 200 and multiply by 1.486. Why does that work? Because 200 is at what time? 14 minutes. What is the 4 minute growth factor going to do for me? It's going to give me the number of the mass 4 minutes later. You can take 100 or 200 times this, and that's the easiest way, given what we have up there. 200 times the 4 minute growth factor. All right, this also works. You could do 50 times the 1 minute growth factor to the 18th. Anyone else come up with a different way?
Proportion.
What's that?
Proportion.
14 over 200 equals 18 over x. Yeah, that's not going to work. It's not going to be based on repeated multiplication. Anyone, Jenna?
Let f of x equal 50 times 2 to the power of x over 7, but substitute 18 for x.
Yeah, that's pretty much like this, right? So it'd be like 2 to the 18/7. So yeah, that's similar to this. You're using the function and basically coming up with this. What's another way to do it? Yeah, Kate.
Could you do 400 divided by the 4 minute growth factor and then times that by 1 minute?
Nice. Okay, so now we're getting creative. So you're going to take 400 and divide by the 4 minute, 1.486. Connor likes this one. And that gives us what? What did that just give us? This is, nope, 17. So this would be how many, what the mass is 17, because 400 is at 21. Divide by the 4 minute growth factor, it takes you to 17. So then we need to? By which one, Connor, or Aaron? 2 to the 1/7, or 1.104. Oh, yeah, let's do that. Yeah, so that's kind of what I'm talking about. Do you know your way around these, right? Or do you only thing you know how to do is make a function and plug into it? Or do you know your way around exponential functions? Like, can you grab other output values and other growth factors and generate outputs that way? So this last one was real nice, right? 400 divide by the 4 minute takes you back to the mass at 17 minutes. Multiply by the 1 minute growth factor to get you the mass at 18 minutes. Okay. Write a function for the mass with respect to n, the number of 10-minute periods. Okay, so we'll call that, say, f of x, where x now is the number of, not minutes, but number of 10-minute periods. Who can do it? See if you can write the function. You think you can do it? Tell me.
So f of
Oh, yeah, because that's what I said.
Yeah.
N. Number
So f of n equals 50 plus 2 to the 10n%.
2 to the, you want to do plus?
What? No, yeah, my bad, multiply.
Yeah, well, that's what it's all about, right? 2 to the
10n over 7.
10n over 7. Okay, and so let's build this from the, that's right. And let's build it one step at a time from the 1 minute. So if I've got the 1 minute, what can I do from there? How can I get the 10-minute? Raise it to the 10. So now that whole thing is the 10-minute, and so therefore to the n. So how many growth factors does that function show? How many growth factors does that function show? 2? Actually shows 3. What's this one? 2 to the 1/7 is r? Which growth factor is it? 1 minute. The 1 minute to the 10th power is the 10 minute. That to the n. So that whole thing you can think of that as a growth factor. What growth factor is it?
It's the Decay.
So it would be the growth factor for what? 10n minutes. It's the 10n minute growth factor.
And decaminutes.
And decaminutes. Very good. I like it. Okay. Let's see. Did we finish that? Yep, we did. So let's give you some practice. Here we go. Okay, so here's the setup. This is number 6, I think, in the homework for this section somewhere. I don't know, but it doesn't matter, you get all the information you need here. The body removes 85% of ibuprofen present every 5 hours after your initial dose. Okay? So you're going to take 500 milligrams. Right, you're going to take 200 tablets, and you're going to make sure you get 500. You're going to take that tablet, and you're going to cut it exactly in half. You get 2.5 ibuprofen, okay, 500 milligrams. So we want n to be the number of 5-hour periods since taking the medicine. So when a function of n, so the function tells you what the amount remaining in the body is at n 5-hour periods, okay? Then I want you to derive, we'll do it one more time. Derive the 1-hour decay factor. Then T is the number of hours, M is the number of minutes, and D is the number of half days. Okay, notice this is half days, not days. So you got lots of work here. This is lots of good questions here. All right, so you're finding the functions, the different decay factors, and percent change for all these different time periods, given a 500 milligram initial dose and 85% decay every 5 hours. Or 85% is that right? Yeah. Your body removes 85% every 5 hours. So you better make sure you get the first couple of decay factors, you better make sure those are right, okay? So before you move on, because everything's going to be based on what you do at the beginning. So check your work at the beginning. Make sure you're interpreting the question correctly. I'm going to take attendance. You can work together, okay? Everyone's writing, everyone's engaged. Where's my attendance?
Yeah.
Yes, sir. Okay. Answer. It's just like that last problem with the size of hours. Hours. So I got
Because it's 1 minute. 1 minute is a 60.
Oops.
You get 1 out of 60. Oh, 60. Oh, that's an hours. Great.
Okay, Jacqueline. How about number 1? So talk to me about how did you build this function if n is the number of 5-hour periods? How did you build that? Initial amount of medicine, okay. Okay. So you're saying the decay factor is 0.15. She wants the decay factor to be 0.15. Agree with that? Decay factor is how much you lose or how much you keep? Okay, so is 15% how much is kept every 5 hours?
Oh,
Is it?
yeah.
Yeah.
Okay, never mind.
Yeah. So she got it. That's it. It's going to be 500 times 0.15 to the n. So here's the thing with these. You got all these different decay factors. Whatever's in the parentheses is the decay factor that matches the unit of your exponent. Right? If n is the number of 5-hour periods, then that what's in the parentheses is your 5-hour decay factor. That's how you can make it easy on yourself. Okay, so how in general, so that means, what does that mean? After 5 hours, how would you calculate the amount in the bloodstreams. So what little calculation can I do here to get milligrams remaining? Carlo, what do you think? Did you hear my question? So I want to know how many milligrams are remaining after 5 hours. What simple calculation can I do to get that? What's that? No, easier than that. Based on this given information here. Times what by 0.15? 500 times 0.15. And yes, that's what you get when you plug in 5 for n. Really? No, you plug in 1 for n, right? Because number of 5-hour periods. Okay, so 75. So now if we were in this process of deriving the 1-hour decay factor, what would 75 have to do with that? What would 75 have to do with that? So, Nick, what do you think? I want to derive the 1-hour decay factor.
Well, you want to take the 5-hour decay factor and that's the word for it. But the exponential part of it, you want to divide by, and you want to divide by 5 in that case, which.
But I want to derive it, so I want to say this 1-hour decay factor, say, is b.
B. So do 0.15 power of 1.
0.15. Yeah, so it's kind of, it sounds a little to me like you're just applying a rule. Are you just applying a rule that you just kind of memorized? I want to derive this. I want to derive it.
No, I'm just trying to get the decay factor. That's what I put. I didn't like do the calculation. I just did 0.15 power over 5.
Right.
That's what it is.
Yeah, that's what it is. So you're right. Because, right, so you remember that if you want 1/5 of the time, you raise it to the 1/5. Okay, so I want to show where that comes from. So how would I show where that comes from? And that's, so if I call that 1-hour decay factor B, how can I use the 75 now, 5 hours later, to find what B is? Faisal.
So first hour it's B.
Okay.
Power of 1.
Uh-huh.
Second hour it's B to the power of 2.
Right.
And then
So on.
And then for 5 hours it's B to the power of 5.
Okay.
Which equals 0.15 to the power of.
All right, so if I multiply that B together 5 times, it would be the same as
75. It's like 0.15.
it's 0.15. You kind of there's 2 different things we can do, and you're kind of crossing them there. So you could do 75, 500 B to the 5th would equal what? 75. So we could reason that start with 500. If you multiply it by this thing 5 times, you're going to get the 75 that we have 5 hours later. Or you could reason that, well, if this is a 0.15 factor, that's going to be the same as multiplying by B 5 times. So if the multiplier on 500 to 75 is 0.15, that's going to be the same as B times B times B 5 times. So either one of these would be a starting point. And when we do that, then we get B equals what? What Nick said. 0.15 to the 1/5. So that's where that raising it to the 1/5 comes from, right? Because if it was B, you would multiply it together 5 times, and it would be equivalent to multiplying by 0.15. So then B must be 0.15 to the 1/5. Okay, so I want the function g. Who wants to do the function g? Freddie, what would that be? which is T is the input is now the number of hours.
So it'll be 500
500.
times
0.15 to the T. What do you think? Did you get it? Is 0.15, does that growth factor match, or decay factor match the units of T? What are the units of T? Hours. So what do we need inside those brackets there? Yeah, we need the 1 hour decay factor, which we just found before. So 0.15 to the 1/5, right? Let's see, did I get it right? So you're thinking, is that the same? I got 0.15 to the T over 5. Yes, it's the same. So yes, it is. But why do I prefer this? Because if you know T is hours, then you're looking at the 1 hour decay factor. Boom, just like that. If you have 0.15 to the T over 5, that's good. But for me, then that takes a moment to kind of reason something out to figure out what the 0.15 is and what's going on there. Yeah.
On questions like this, is it better to use like the exact expression that, or is it okay to find like?
So this,
1
yes,
to 1 over 5?
this is better because it's exact. But in order to get the 1 hour percent change, you're going to need.
Okay.
Yeah, but like this is represents an exact function now. If you find that value and plug it in, well, you're going to round and you're going to get something really close but not exact. So it's kind of like what makes sense in the situation. And here we're building functions. It makes sense to just keep them exact. Okay, how am I going to find the 1 hour percent change? Allah.
So basically, we're going to take the square root of the 0.15 or 0.15 raised to the 1/5, and we're gonna get the 0.68.
Okay, let me do that. Let me just do that real quick. 0.6842, is that what you got?
Yes.
Okay, and therefore?
And therefore, the percent change is going to be 1 minus that. I think it's going to be 0.32.
0.316?
I got 0.32 or 0.3%. Yeah.
So 0.316. So what's the percent change? Percent change. 0.316 the percent change?
No, it's so it's going to be 31.6%.
Okay, 31.6%. Is that the percent change? Yeah. Jacob.
Oh, no, that's negative 31.6.
He wants negative 31.6. Allah, you agree? Okay. Yeah, so negative 31.6. I don't know why it's putting 0.60. So what would be 0.58? Is that right? Negative 31.58%? Did I get that right? Cool. Okay. All right, minutes. Function for minutes. Sean, you're up.
I did the 500 times 0.15, and then I took m divided by 60 to replace where the t is.
Okay.
And then that is divided by 5, all in the upper power.
Okay, so, yep, that works. Can I write it out one factor at a time? So let's start with the 1 minute. And how would I get the that's the 1 hour. How would I get the 1 minute?
Divided by 60.
wouldn't be divided. If I'm starting with the 1 minute decay factor and I want the, sorry, I'm starting with the 1 hour decay factor and I want the 1 minute. So yeah, you would divide the exponent by 60, or you could just take that 1 and raise it to the 1/60th. And then that to the m. Let's see, did I have that right? It's getting a little hard to see with the parentheses. All right, so 0.15 to the 1/5, that to the 1/60th, that to the m. I think it's right. So yeah, so you can want to combine all that into one exponent. What would it be? What would the exponent be? 0.15 to the m over 300. If we want to make it nicer to look at. But what happens there is then we lose what happens, right? If we do that, m over 300 is correct, but we lose the process. And what this shows nicely, all those decay factors along the way, right? It shows the 5 hour, the 1 hour, and the 1 minute, and then the m minute. So that the whole thing is the m minute growth factor. Okay, percent change. How do we get the 1 minute percent change? Who wants to help me with this one? Cecilia, did you get it? I'll get you next, Connor. Did you get the 1 minute percent change?
I'm doing it right now, but would it be 0.15 to the 1 over 300?
Okay. And I'll calculate that. I get 0.9937. So what's the 1 minute percent change then?
So it'd be 1 minus.
Good. Right. Times 100. So it'd be equal 100 times
1 minus 0.99.
I hope this is right. Darn it.
It would be negative.
Didn't like what I wanted to do. Equals 100 times 1 minus that. Why is that? That should work. What?
Put the multiply sign.
Yes, thank you. But then when I did that, it didn't. Oh, right, because I multiplied by 100. So this is the percent.
It should be negative.
It should be negative. Thank you. Right. Okay, this is the percent, right? So less than 1% every minute. You lose 0.63% every minute. Okay, half days. Here we go. Half days. Who's not helped me out yet? Sarah. Half days. Can we do it? Can you do it on the fly here? It's easy. Work off the 1 hour, and you can do it pretty easily. So work off the 1 hour. What's that? Right, it'd be 12 hours. So what's our structure? So what's the structure of our exponential function? Initial value, right? What's the initial value? 500. And then what? What's that? 0.15 to the 1/5. And that to the, but that's the one, this is the 1 hour, right? And this is the 1 hour, not, we need a half day. Now we need a half day growth factor. So how do we get the half day growth factor from the 1 hour growth factor? We're going to times it together 12 times, right? So that would be to the 12th, right? To the 12th. And then to the D. So we got the 1 hour, raise it to the 12th. That gives us 12 hours or half days. And then to the day, every day is a D is a half day. Half day percentage. We're going to take that thing. Equals negative 100 times 1 minus 0.15 to the 12/5. Is that right? Oh, crying out loud. Oh, it just doesn't like it at all. What did I do wrong? Oh, thank you. Every half day, it goes down 98.9%. Okay, questions on this example? Really good. Is that, no. Okay. Anything? Any questions? Yeah, Jacob.
So does that never hit 0 then?
Okay, theoretically, yes. If it truly removes 85% every 5 hours, then theoretically, forever you will have a tiny little bit, right? Okay, so this is just really modeling. So of course, after a couple days, you're not going to have any more. You're going to so basically, we're looking at maybe a half day or a day. We're trying to model how much is in there. And so the best model or a good model will be exponential growth. Theoretically,
eventually in a real life
situation, it's going to go to 0. But modeling it along the way, this is a really good model of that. It's not exact. Okay, so let's, we got one more thing. So we're talking about these, so what's the centerpiece of exponential growth? What's the centerpiece? What's it all about? Multiplication, growth factors. I heard it. Good. All right. Growth factors or decay factors. All right. Growth factor is a multiplier. Finish the statement. It's a multiplier. Why are you giving me those eyes? That's what we've been saying for 2 weeks. Growth factor is a multiplier. And what comes after that? Andrew.
Multiply the previous output to get the next output. However many times it has the...
Right, exactly. He said you're going to multiply an output by the growth factor to get the output for as many times as the input's gone by, right? So in general, it's an output. It's a multiplier and output to get another output. The output quantity is the one that's growing exponentially, growing by repeated multiplication. All right, what stays consistent from output to output? As we change from one output to the next, what stays consistent with exponential growth? Okay, of course, the growth factor, but what else does?
Percent change.
Percent change, right? Percent change is another way to characterize exponential growth. You have a consistent percent change. And we know that growth, the relationship between the growth factor and the percent change is the 1 plus R, where R is the decimal version of the percent change. Okay, you want to do some more? You're not sure? Do you want to do some more? Okay, have a good weekend.